Hello, everyone, and welcome to today's webinar on empowering your design workflow with Creo Multi-body Design, allowing you to separately manage, visualize, and design multiple geometric volumes as individual objects within a single part. My name is Alex Janicki, Director of Marketing here at TriStar, and I'm very pleased to introduce our presenter, Emily Pinto. She's a virtual pre-sales specialist at PTC. Before we get started, I just want to do some quick bookkeeping and mention that this complimentary recording of this webinar will be sent to everyone who registered automatically, as well as available on our website and YouTube channel shortly after the presentation. We do encourage you to, share on social media to your colleagues, anyone that you might find valuable. If you have any questions during the presentation, please feel free to leave them in the chat and we'll hold a brief Q&A at the end of the presentation. And before I pass it over, I did want to briefly go over TriStar for any of you not familiar with us. So at TriStar, we're a company that specializes in helping manufacturing companies adopt systems and processes to enable better and more efficient product development. We achieve this by being the largest value-added reseller for PTC products and services worldwide, with headquarters in Phoenix, Arizona, and representatives and engineers throughout North America, Canada, and Mexico. We've been in business for over 25 years, and we're experts in CAD, data management, PLM, automation, and product development. We also have a large assortment of custom solution services and support packages that are really tailored to specific achievements and needs. Finally, I did want to mention that there's some great Creo and Creo extensions promotions expiring the first of the year. So I encourage you to contact one of our sales representatives at the end of the presentation for more information on those offers that are going to be expiring here soon. And with that, I'm not going to waste any more time. I'm going to go ahead and pass the reins over to Emily, and we shall get started here.
All right. Can you see my PowerPoint all right?
Yes, we can.
Perfect. Okay, so hi, everyone. My name's Emily. I work for PTC, as Alex mentioned, in the Virtual Center of Excellence. So I'm here today to talk about multi-body design. So this is just going to be a very high-level overview. Let anybody know, maybe things that you didn't know about multi-body and Creo. It's a relatively new feature. So hopefully this can help you take advantage of some more effective workflows going forward. And really that's what multi-body design is. So it's just another way to work. It's another design tool that you have available for you. If the traditional way of doing it maybe was a little bit more complex, and there are some very particular tasks, I should say, that are design tasks that different people might use that are much easier to do with multi-body design than it would be without it. So that's a little bit about what we're going to talk about today. If you happen to do any of these types of modeling or anything like that, then it would be a good example. But I really do urge everyone to go in and play around with multi-body design, because you might realize that there's maybe this is a more effective way to do something that you usually do. So we're going to talk about the challenges, why we added multi-body design into Creo, talk about the solution, the capabilities, and then I do have a short demonstration to show you an example. We are going to talk about a lot of the concepts and use cases in the PowerPoint, just because it's a little bit easier to get the information across, and then just a little demo example that we have towards the end. So the challenges here are that people are always trying to drive innovation. Products have to be different, they have to be relevant, competitive, and more challenging usually to design. And it can definitely be. Oh. I'm not sure how to undo that.
Okay, well, so it looks good on my end.
Okay, I'll it's the my controls here, but that's okay. I guess I don't need those. So the innovation can really be difficult when you have a skills gap. You have a lot of people who've been working in Creo or in a design tool for 30 years, and they leave, and now you have people who are new to design, and things can be difficult to design. You need to put your intent in there, and you need to make sure that the design is flexible going forward, and it gets done quickly because you really need to get these made. You need to get more done in less time to keep up with the market and to meet your deadlines that are, it seems, ever shortening. So really one of the solutions here is multi-body design. And this is not a new concept in the design world, but it is new to Creo. And we could always do the types of it's not anything special that you're able to make that you weren't able to make before. You're still able to make everything using the traditional Creo techniques, but you now have this in your tool belt as well, and it really does support flexible and efficient design of parts. And you'll see that the ability to automatically ignore construction bodies, right? You can actually create whole parts that you can just define as a separate body, and then your bill of materials will be able to take advantage of that. So I guess these are going to be supported. I have a couple of slides here to show that they're supported through almost the whole Creo parametric functional areas, all the different extensions and applications. Multibody is going to work very seamlessly. So at its core, what it is it's the ability to define certain geometry as a separate body within a single part. So you are now able to have separate entities inside of a part, which means if you're creating maybe some kind of a tubing system or whatever this is here, you can define that as a part a body that's separate from this body, and then you're able to do things like add the geometry, subtract the geometry, merge the geometry between bodies. You can change the appearance of one body and not the other. You can change the material properties. You can change, like I said, you can mark one as a construction body. So maybe it's easiest if you have to remove material or if you have a void of some sort. And you really, the easiest way to model that is to model it as a solid and then build your part around it or subtract it. That's going to be super easy to do now with bodies, because you can build all of the different geometry that you need as solid geometry and then just decide, do you want to use that to subtract? Do you want to merge them? Do you want it to just be construction? It's really, really effective. And so that's where we get into bodies as design tools. So one of the biggest uses is a design tool throughout the modeling process. You can simplify and manage your geometry creation. So you can avoid doing temporary assemblies where you combine different part files. It can all be done now with bodies within a part. So it keeps that file structure, that part structure clean, because you don't have to have temporary parts or construction part. It's all within your part file now. So it's less entities to manage. And you're able to still utilize bodies from different parts. You can pull them in from libraries using data sharing features like copy or publish. So you're able to take advantage of bodies from interacting between parts. And then you can use these different bodies for adding geometry, subtracting geometry to get to a model that would have been much harder to create otherwise. So this example here, which we'll actually see in a demo, this is much easier than trying to pattern surfaces, right? You just make a solid bar and then you pattern that. And then you can have additional body operations. So like bodies can be used for doing splits, mirroring. There's a lot of different uses that you can use at any point now throughout the design. And things like intent edge support, right? You can do all these functions all within a single part if you'd like to. So it's right, the Boolean edge support. So it's very useful for creating things like this, which would have been more difficult without it. Now you don't have to use these, of course. There's still everything that you used to have in Creo is still an option, but this does open up a new workflow. So for example, using it as subtractive geometry, another main use for these bodies. It's a very fast and efficient way to model that you'd like to remove from a solid that you already have built out. So for example, let's say you modeled this piping system in another part. You can create those pipes as solid bodies, as a construction body, copy and paste it into another part, and then just subtract it from the part that you need to, and it leaves that perfect cavity. So it's a more effective way of being able to communicate design characteristics and intent, from part to part. You can also create solid bodies by representing cavities in subtractive geometry. So you're essentially creating a solid body for that cavity. Makes it much more visually clear. So this is a lot about visual clarity as well. You can change the appearance of it. You can look just at that cavity part. So it gives you more options for working with that cavity. You can actually design it as its own entity and then control it from there. So really makes it easier to understand, the ability to add transparencies and different representations. Really, honestly, even if it's just for visual clarity, sometimes it's useful to build these geometries in a separate body, just for the fact that it makes it easy to see what's going on. We also have what's called a master model methodology. Bodies can be used for this master model methodology, where you can use the Boolean operations for faster in-context design. So things like split body, copy body, pattern body, all for laying out those interfaces. There's also the idea of indicating space claim for the final part. So you can use that body for designing that space that you're going to have a space claim for. From there, you'll be able to extract different parts from that single part design for reassembling into the final assembly, where they can all be added to a bill of materials. And finally, you can update those bodies where you'll receive notifications on how that updated your master model. So you can manage what's changed, what's out of date, and decide how that gets propagated to your final assembly. So it gives you a new entity that you're able to keep track of or manage or monitor as your assembly changes, something that you're able to now control. So you can put best practices, you can put all sorts of different notifications to make sure that all of those different spaces and entities are changing how you'd expect them to. So this is really useful. Also, I'm not sure if I mentioned, you are able to take a body and create it as a part, right? Extraction of bodies to parts. So not only can you move a body from one part to another with copy geometry, but you could also take so if you have a part and you have multiple bodies in that part, and you decide, okay, I know I created this body inside this part for context, but actually I want this body to be its own part. You can then go to that body specifically and say, make new part. It'll make it a new part. So it gives you the ability to work in context, almost similar to like an assembly level where, you want to have multiple parts designed at the same time. But now you don't have to do that. You can do it at the part level and create a new part from one of the bodies. That's a really useful tool that's available here with this. So getting into some of the capabilities, where else is it, pretty obvious there to PTC that there's going to be a lot of benefits, right? Like I said, there are certain things that Multibody really makes more efficient, and there are certain things that, okay, maybe it's not so much more efficient to do it the old way. But sheet metal design has a couple of very obvious use cases. So if you work with sheet metal in context of other bodies, this is where Multibody can help us. So basically, you can convert a body straight to a sheet metal part. So there's a specific UI tab for sheet metal bodies versus your traditional bodies. So you can still utilize copy geometry features to insert regular bodies into the sheet metal design, but you're then able to subtract those bodies from the sheet metal part to get specific geometries that you might need. And finally, where you can get that flattened version of the sheet metal body towards the end. So that's just one example of where this might be useful. Another example here, flexible modeling. It's another area that these are, you would often use Multibody as a design tool. And once you have different bodies, you can translate them, move them, rotate them. So like we said, you can split things into two separate bodies. So let's say you design, this part, and you decide, actually, the second part that sits with it needs to be on an angle. So you could just create that as a solid, and then as a straight across, split the bodies and rotate half of the body. So this makes it very easy. You don't have to now make all of these things on an angle. It's a very effective way to do, even if it's just for concept design, which is where a lot of times we see flexible modeling being used. Hey, what if I wanted to change the angle that this sits? Great, split it, turn it. Not a lot of parametric, definition that you need to do to see that change, and then decide if you like that method and you want to go forward. Once you've made the flexible modeling change, it goes back to standard multi-body functionality. So you can merge things, subtract things, especially for any late stage design changes. You can make bodies and still make great use out of those multi-body tools. So when you're done, you have a nice part. So the next section here, additive manufacturing. This is almost, a no-brainer in terms of effective ways to model additive features. You can use multi-body to create, manage, and visualize lattice structures. So if anyone's used additive manufacturing, if you have the additive manufacturing extension, you hopefully have used the lattice feature, where you're able to shell a body and fill it with a lattice, or you could even, take a void and fill it with a lattice. There are lots of different options for taking a part and filling it with a lattice, because that's how lattices are defined, right, within a boundary. And now with body definition, you can have within a part 2 or 3 separate bodies, and you can choose just one of them to add lattices to. And that makes it very easy to define where you want that lattice to act. It's also very easy for 3D printing. You can choose different colors, different materials for different bodies. Additive opens a lot of new options, where multi-body gives you the ability to explore that, because traditionally, if it's a part gets one material definition, one color, right? And so if you want to print things with multiple colors, multiple materials, you'd have to have an assembly then, where with multi-body, no problem, change one of the bodies to whatever you want it to be, that's different, send the part, just the single part file to print, and it will be able to, take advantage of that. You're also able to define printing strategies by different bodies. That's really the key to multi-body. It's a separate, you can define separate entities that can be controlled independently of each other within one part. And that extends to printing strategies. So if you need a thin wall strategy for part of your part that has thin walls, great, define that area as a body and assign a different printing profile. Very useful. You can also work with bodies independently, still go through the printing process with each pieces. So if you decide, actually, I just want to print part of the body or part of the part, you can hide that other body and move forward. So you can actually choose which bodies you'd like to print. Gives you another breakdown beneath the part level. It's really useful, especially because now you won't have a ton of different parts and assemblies and temporary things, and really cleans up your model tree. So simulation, this is another area where it's very effective to use. Bodies can be defined for different design purposes. They can be assigned different materials as required for analysis. You can define the cavity. It makes it very easy if you're doing flow analysis or something of the sort. Define the cavity. Don't worry about the big part around it. Just build out that negative space, but define it as a solid. It's much easier to do. And then when you're ready to make it into a full part, you can just subtract this from the part around it. You can define them separately. So very, very effective. You don't have to worry about, removing material and this and that. And it's just, hey, this body's a negative space, subtract it from the whole. So this is how they can be used as construction geometry to define the analysis setup, reflect accurate mass properties. Again, right, if you have a force that's acting on one little area, make that little area a separate body. And then you can say, instead of trying to say, you know, only act on this surface, you just go, this force applies to all of body one, and much easier to move forward with that. You can define cavity bodies, right, as I mentioned. So this is that simulation inside of the cavity. One of the great things for simulation, also a lot of construction geometry goes into simulation. Sometimes if it's a complicated setup and you need to apply forces and constraints in different areas, make them all bodies, define them as construction. They won't be added to your bill of materials or your mass calculations or anything like that. They're just an entity that's used for you know, selection purposes, basically the construction body. So really useful. And they can be moved to define positioning strategies using simplified representations to simulate different configurations. And that's a really useful tool as well, especially for, you know, if you're simulating all those different configurations, this could save a lot of time. All right, generative design. This one is very similar. Generative is going to work in a particular area. You define it as a part, right? As a body. And so you're able to define different bodies as input geometry. So if you have certain things that work, that you know, it's going to work on particular pieces of your part, and you want it to keep those and just add geometry in the middle, define those as two separate bodies. Use one as the keep-in geometry and one as the envelope for it to work within. And you're able to use multi-bodies to manage and visualize the results as well. So when this gives you the results, it's a separate body. You can bring it into, you know, B-rep representation, so convert it into freestyle, and you can add it to your part. So it's really effective for doing that. So you can see here, this is the reconstructed geometry. So this is editable geometry as the output of your generative design, and you're able to do with that what you want. So merge it into the rest of your part, create a new part with it. Maybe you want it as its own body, whatever you would want to do, you know, define it. You can also use the construction body concept to reflect the correct mass. So that's another option. Okay, so multi-material parts. This is a great option for multi-body, and really this is one of those areas where it's difficult to do it without multi-body, because you have to have things at the assembly level then if you're going to have those multi-material parts. So for example, overmolded, you know, something like that. You can improve the design visualization and clarity. You could now change the appearance to say this is the part that has the different material, and then define the material there. It also encourages and facilitates reuse. Great, you have this overmold that you're going to use, make it a body, and then you can bring it into other parts as needed. It also supports the supportive body concept for parameters, relations, mass properties, analysis feature. You can now run reports that include it and don't include it, different things like that. And there's support for mold design using reference parts. This is a great use as well, because you know, in areas that you need reference parts for merging, inheritance models, things like that, this is going to be useful. Okay, talking about drawings and then our Unite technology, and we'll hop into the demo. So drawings also support the work that's done with multi-body. If you have multi-body, multiple bodies defined in a part, and you bring it into a drawing, you can see that body breakdown in the drawing as well. So it can list the body information. It can bring it into repeat regions for tables. You have the drawing template that's added for the use of multi-body design, so you can even take it into account in the template. And then you can start doing different things with it. So maybe you want to modify the cross section and hatching for each body. You can do that now because they're separate bodies, so you could just apply it to the whole body. You could copy the hatch to allow copying of hatching properties from one section to another. If you want all of, you know, the bodies with this material to have a certain hatching, or bodies with, you know, whatever it might be. And then Unite. So when you're bringing this in, if anyone's not familiar, Unite technology is our technology for non-native CAD data. So importing, exporting, opening, interpreting different, you know, different CAD platform styles of geometry. And this also supports multi-body. So if you have a data exchange, let's say that you're bringing in a part from SolidWorks that has multiple bodies defined in SolidWorks, you can bring those over now, and it will have all that information that you can preserve. So you can maintain that multi-body definition for exported and imported geometry. If you export this to someone, you can keep the bodies with it and say, you know, the body definition basically, and say, okay, here, and then tell them, all right, well, we're looking at body number 2 and there needs to be a change, or this is what we were thinking. Creo also preserves the multi-body if you are exporting to manufacturing or something like that. This is an example of like a PVZ where you're able to keep those definitions for appearance, so it's much easier to tell what's going on. And then if you wanted to interrogate it at all, or you can actually understand what the part is doing, you know, taking into account different bodies or not. Okay, so we are going to jump now into the demonstration. I know the concept here is relatively straightforward, but it's not until you really start seeing examples, hopefully all of the examples we went through here in the PowerPoint, that it really kind of starts to click, because it is a very effective way to do things. It can be used all over. Like I said, Creo has multiple extensions and everything that you might want to use it in, and it's supported across across all those. So it's a useful tool to take all the way through your design process into machining or something like that. So this is an example here, just a quick example. And multi-body, it's just a design method, so nothing too fancy. Make some extrudes, choose your sketch regions. So for anyone who doesn't know, this is sketch regions, which is not too new. It's been around for a couple of years, but you can select just certain pieces of a sketch to do something different with. So this isn't even multi-body. What is multi-body is this body 1. So you'll see now when you're creating features, the body options will always be one of the menus if you're able to create that as a separate body. So you can see that the selected body, the default, is body 1. And that's always going to pop up top of your model tree. You can see in the model tree there's bodies. There's only one body so far defined, body 1. So it's always going to default to body 1. So if you don't specify anything, you're always going to end up with a part, it only has one body, that's the part. So if you don't want to use multi-body, you don't have to worry about it. There's nothing special you have to do now that this is in here. The only difference is that if you do want to use multi-body, you can check create new body, and now you'll have 2 bodies over in your model tree. So you can filter for these. If you want to go to the body for the model tree items, you can see body subnodes. You can change the appearance even, so you can do all sorts of filtering from there. You can see which different features are in different bodies. You can hide and show, right? Change the color. And then once you start modeling, it's going to default to the body that you started in. So if you're going to make another extrude, of course, this is going to be added to body 3. You add something there. Now, if you want, you could create a new body for that as well, or not. And if you decide any of these features that are in one body you want in another, not a problem. You can add, subtract, merge. We'll get to that in a minute. But for example, rounding, maybe you want to round all of the edges of one body and not another, that's okay. Or you can do things to multiple bodies, so you can still make features across, if you have 2 bodies defined, but you want just one round feature, not a problem, you can still do that. But the benefit then comes, okay, let's say you want to shell this part, you don't want to have to try to define, if it's complex, maybe you don't want to define different surfaces and stuff, you can just do it by body. So now you can just say, give me this whole body, shell it, and you'll see that second body obviously didn't get shelled. And so that's a really easy way to define feature creation. You can do things to one body that you don't want done to the other. You can merge them, so you'll see this is all now part of body one. So maybe you don't want two bodies going into manufacturing. Maybe you just wanted to use it because you want a shell. You can very easily, okay, great, you have a design, split it into two bodies, do something to the other, one of the bodies that you don't want done to the other, and then merge them back together. That results in still only one body, but it made it very easy to do that feature change or that edit. So now, for example, here, you can choose this extrude, create new body is in your right-click menu as well. And that pops up, body 7, you can change the color. So very effective, very useful. Hopefully you can see why it would be easier to do certain things with this method than another. One example is things that you have to make complicated surfaces for, especially if they're construction geometry. It's much more effective to make it as a solid body because it's just easier to work with, easier to think about. So for example, this is the part that you saw in the PowerPoint. You have this yellow piece, you want to create some grooves in it, create a piece, and then select new body. So this is no longer just an extrude, this is a whole separate entity. And now that it's a separate entity, you can get it to the way you want, chamfer the edges, right? If this was a surface, you couldn't just chamfer those edges. So that makes it way easier to work with. And then define how many you want, so pattern it out. If you want 27, great. And this will go match past. Now, right now, they're two separate bodies. You can hide and show both, another advantage. You can still work on that first body. So for example, if you want to offset, and these bodies might interact, but unless you define the Boolean operation that you want to happen, that doesn't matter at all. So, if you want to add this geometry to body 4, this will list all the bodies you have. So you don't always have to create a new body. You can make a feature and then go into body options and just select the one that you want to add it to. So that's going to be a part of body 4, right? So you've cut that there. And then you can subtract. So you have merge, intersect. Like I said, these bodies can intersect each other all day. Until you define what that interaction is going to be, it doesn't matter. So you can say, right, this is going to be intersecting, it's going to merge, where obviously you can subtract. Okay, and then just one more example about how this works with the extensions. I mentioned that Multibody is supported across, a lot of the Creo functionality, especially going to simulation or manufacturing. And it's actually necessary with generative design, right? So for those multiple input bodies. This here is going to be the additive example. So if you have additive manufacturing, this is a great way to do it. You can see here that there are already two bodies. There's the main and body 3. You can rename these, right? So you have main body and lattice body. You can change the appearance of one of them, make it partly translucent, or you can see through that there. Then you can choose which one's your default body. So now you're in the lattice. For anyone who's not familiar with our additive manufacturing, it's very easy to make lattice features. If you have the extension, you'll just see this lattice option will be a clickable option. It opens up your menu, and then you choose what kind of lattice you want, 2D, 3D, formula driven. You choose, there are a lot of ways to choose what region you want the body, the lattice to take up. But the easiest by far is replace a part with a lattice. And if you have separate bodies, you can be very precise about which parts of that you want to have filled with a lattice. So this is your example unit cell. You can choose your first cell position, and that body that we named lattice, we can shell and add a lattice to. It makes it really just a single click to say, this is where I want my lattice. You can change the cell type, the wall thickness. So right now it's a little thinner. Density, the formula driven have less options because it's driven by a formula. But if you have a beam or something. So now you can see here, Your lattice is taking up all of that inside space. It's shelled. You can change the appearance. And if you wanted to have that outside shelled part as a body and the lattice as a third body, you could do that as well. You could select the lattice feature and say, let's split this into a new body, and then you could do what you want with all of that. So maybe you want one material, for the shelled part, and then one for the lattice. So that's really the idea behind multi-body is, let's give you more ways to work, and then you'll, if you play around with this, you'll be able to, once you know that this is available for you, you can really come up with some advanced design workflows where it's much more effective to design that way. It's cleaner, it's easier to see what's going on, it's easier to manage. It's a really effective way to do complicated things easily. You can design multi-material parts that no longer require some fancy, fancy logistic work with different parts and assemblies, and you can have now a single part that you send to someone that has multiple materials defined. It reduces the referencing complexity. It's very easy to, to create different entities using these bodies instead of coming up with crazy referenced workflows. And it really allows, more usability and productivity because it's faster to get to what you want to do, especially with simulation, manufacturing, things like that are going to be much more productive because being able to define and control different entities within your body is going to be so much faster and easier. So that's all I had to show for today. I can pass it back over to you, Alex. Thanks for sitting through my PowerPoint with me, and I hope that we were able to give you some ideas. Jumpstart, it's difficult to really come up with a defined way of this is how you should use multi-body, because it's not. It's another design tool. So we can help come up with some ideas and some ways to use it, but this is something that really will become more effective the more that you use it and play around with it and find where it fits in your design process and maybe where it doesn't. So thank you, everybody, and Alex, back to you.
Excellent. So while we hold a moment for questions, I just wanted to reiterate there's some great limited time offers expiring at the end of this year. So, after this presentation, if you want to reach out for more information, want a more thorough demo, definitely don't hesitate to contact us or visit our website. Let's just give it a moment here for questions. And it doesn't look like we have any. Guess you left them speechless, Emily. Nice job.
I think I said enough words for everyone today. All right. I don't see any questions.
Could someone raise their hand? If you want to go ahead and just leave your question in the chat, we can certainly answer that.
I'm not sure where.
Okay, there we go. Or like a comment, but maybe you have some comment on it as well.
Help organize
attendance, basically just say it seems like it can help organize surfaces.
Absolutely. Yep. Yeah. So surfaces is, one of the areas that multi-body is really useful for, because those can be difficult to manage and organize. So if you create solid bodies instead and just use those as the surfaces, that's a very, very effective way to have a little bit more organization and controllability to different surfaces you might have. So absolutely, that's a great use case.
Yeah, he was just following up and just said, I used to have difficulty with advanced surfacing techniques and keeping track of them. It does seem like this is probably the ideal solution.
Yep. Yeah, you can create that surface part, add it, all right, here's a new body, and then, use it as construction or something of the sort. Yeah, a couple of different ways to approach that, but definitely a great use case.
All righty. I think that is all. And again, if you have any more questions, again, visit our website. Our representatives are standing by, ready to schedule, more in-depth demos. And with that, I just wanted to thank you, Emily, again, and thank everyone who attended. If you enjoyed this presentation, once again, we do encourage you to share the on-demand recording with colleagues on social media or email. And definitely take advantage of some of the offers we have on these extensions. You'll also find additional replays and more, as well as free trial links on our website. So thank you again. Enjoy the rest of your Thursday and Friday and have a wonderful weekend.
Bye, everyone.